Today, we're going to crack the code on chance. We're building a powerful toolkit for understanding probability so you can decode the odds in pretty much any situation. Let's get right into it.
You know the feeling, right? Whether you're playing a game or just checking the weather, you've probably asked yourself this exact question. It can feel like some big mystery, but honestly, it doesn't have to be. Because here's the thing about probability. It's not some kind of magic. It's a really practical set of tools. And over the next few minutes, we're going to build that toolkit together, piece by piece, so you can tackle any problem that comes your way.
First up, we've got to build the foundation. This is the cornerstone of our entire kit, the one tool that everything else relies on, basic probability. So what is it, really? Well, simply put, probability is just a number that tells you how likely something is to happen. It's on a scale from 0, meaning no way, it's impossible, all the way up to 1, meaning, yep, it's a sure thing. Now, don't let the formula look intimidating. The core idea here is actually super simple. All it really means is you take the number of ways you can win, your favorable outcomes, and you just divide it by the total number of things that could possibly happen. That's it. Okay, let's put this first tool to work. Classic example, rolling an even number on a regular 6-sided die. So first we count our wins. In this case, that's the even numbers 2, 4, and 6. So there are 3 ways for us to win. Next, we count up all the possibilities. A die has 6 sides, so that's 6 total outcomes. The last step, we just divide our 3 wins by the 6 total possibilities. That gives us 3 over 6, which simplifies to 0.5, or a 50% chance. See? Our first tool works perfectly. Okay, time to add another tool to our kit. And this one's kind of like a secret weapon. It's a really clever shortcut for solving problems that seem super complicated at first. It's called the complementary event. The idea behind this is incredibly simple, you'll see. For any event, let's call it A, its complement is just everything else. It's the event that A doesn't happen. You know, if there's a 30% chance of rain, what's the chance it doesn't rain? Yep, 70%. The probability of something happening plus the probability of it not happening always adds up to 1, or 100%. So why is this a secret weapon? Well, this quote from our source material absolutely nails it. From now on, whenever you see a question asking for the probability of at least one of something, a little alarm bell should go off in your head. That's your cue to think about the complement. Think about it. Trying to calculate the odds of getting at least 1 6 when you roll 3 dice? That's tough. I mean, you could get 1 6 or 2 6s or all 3. It gets complicated fast. But what's the opposite? The complement is getting no 6s at all, and that is so much easier to figure out. You just calculate that probability, subtract it from 1, and bam, you've just solved the hard problem. It's a beautiful little trick. So far, we've only been looking at single events, but the real world is messy, right? It's more complex. So what happens when we need to handle 2 or more events at the same time? For that, we need our combination tools. Okay, this right here is probably the most common point of confusion, so let's break it down. We have to know how events relate to each other. On the left, we've got mutually exclusive events. The key phrase to remember is can't happen together. You can't roll a 1 and a 6 on a single die roll. It's one or the other. Then on the right, we have independent events. Here, the key phrases don't affect each other. Rolling a die has 0 impact on flipping a coin. Getting this distinction right is absolutely crucial for picking the next tool. So, our first combination tool is the addition rule. It's perfect for OR questions. If we want the probability of A or B happening, we add their individual probabilities. But, and this is the important part, we then have to subtract the probability of them both happening. Why? Well, if we don't, we've actually counted that overlapping area twice. So subtracting it once makes sure our count is accurate. Now, check out what happens when we use this rule for mutually exclusive events. Remember, they can't happen together, which means their overlap is 0. So that subtraction part of the formula we just saw, it just vanishes. It simplifies down to just adding the 2 probabilities. It's a great example of how all these tools are logically connected. Next up is a really powerful idea, conditional probability. This tool helps us find the probability of event A, given that we already know event B has happened. What's so cool about this is that new information changes everything. It basically shrinks the entire universe of possibilities down to only those outcomes where B is true. So how do you know when to use this tool? You gotta look for the signal phrases in the question. Things like given that or if we know. Those are huge clues. For instance, the probability of drawing a king is 4 out of 52. But the probability of drawing a king, given that you know it's a face card, that's totally different. Your world of possibilities isn't 52 cards anymore. It's just the 12 face cards. Your denominator, the total outcomes, has changed. All right, we've made it to the final and maybe the most practical tool in our entire kit, expected value. This is where we take everything we've learned about probability and use it to actually make predictions about long-term results. At its heart, expected value just tells you the average result you can, well, expect if you were to run an experiment over and over and over again. And what's really cool is how it connects back to another idea. It's basically just a weighted average. But instead of some arbitrary weight, we use the actual probabilities of each outcome as the weights. Pretty neat, right? Let's see this thing in action. Imagine a card game that costs $5 to play. You win money if you draw an ace or a king. This table lays it all out for us. For each thing that can happen, we list its value, the profit, and its probability. Then you just multiply the value by its probability for each row. So the last step is to just add up that final column, and the result is negative $2.69. Now, this is the most important part to understand about this number. It does not mean you can lose exactly $2.69 on a single game. That's impossible. What it means is that if you played this game 1,000 times, on average, you would lose about $2.69 per game. It's a really powerful way to see if a bet is worth it in the long run. And for this game, it's definitely not. And there you have it. From the very basics all the way to expected value, you now have a complete, ready-to-use toolkit for decoding chance. And this final slide, think of this as your cheat sheet. It sums everything up perfectly. When you see a problem, just look at the language. Does it say not? Use the complement. Does it say or? Grab the addition rule. Given that, that's your cue for conditional probability. This sheet helps you match the words in the problem to the right tool in your kit. So, you see, probability is no longer a mystery. It's a set of powerful, logical tools. And now, they're your tools. So the only question left is, what odds are you going to go out and conquer first?